Good morning students. Welcome to your online class. In today's class we will start our chapter 11, that is work and energy. So let's start with the first topic, that is work. What is work? Everything that we do in our daily life, in our daily routine is work. But in scientific term, it is not work. In scientific term, we write work done in place of work. That means in science, work is done. So we will name it as work done, and simple work is our daily routine activities. These daily routine activities are come in work. For example, playing, writing, reading, eating, anything. These are considered as work. But in scientific term, what is work done? Suppose here is a body of mass m placed at this surface, and when we apply a force of F Newton, and due to this applied force, if the body displaces to a new position, this is the previous position, this is the new position, then we said work is done. That means in scientific term there are two requirements for work to be done. Two requirements, or you can say two necessary things for work to be done is, first one is force applied. You must apply a force on the body, and the second thing is displacement. That means the body must displace from its original position. These are the two things which are required for work done. So now how we will define work done? We can simply define work done as, work done is the product of force and displacement. I am writing force with symbol F and displacement with symbol S. So work done is the product of force and displacement. The symbol for work done is capital W, and it is simply written as force multiplied by displacement. F into S is work done. Now as we know, every physical quantity have a unit. What is the SI unit for work done? The SI unit for work done is joule. And how we can define 1 joule? If 1 joule work is said to be done, then what we require? We require 1 Newton force, and this force must displace a body through a distance of 1 meter. So I'll write here meter. From here this simple relation, 1 joule is equals to 1 Newton meter. As we know, the SI unit for force is Newton, the SI unit for displacement is meter. So 1 Newton meter is equals to 1 joule. We can simply define 1 joule as, when a force of 1 Newton displaces a given body with a distance of 1 meter, then 1 joule of work is said to be done. So in this way we will simply define our work done. Let's take a quick revision. What is work done? For doing work we need two things, force applied and the displacement. And how we will calculate work done? Work done is simply the product of force and displacement. We will represent work done by capital W, force capital F, displacement S. So work done is force into displacement. The SI unit for work done is joule, and 1 joule is equals to 1 Newton meter. Students, there are some more relations to work done, how we can calculate work done by different formulas. We will also discuss the different methods to calculate the work done. So let's discuss all these methods. I am writing here methods to calculate work done. The very first method, as we know, work done is force into displacement. So if the question is given like this, a force of 10 Newton is applied on a body which displaces it by 2 meter, then calculate the work done. We will simply use the relation work done is F into S. That means the condition for this formula is when force is given. जब आपको फोर्स की वैल्यू फाइनाइट बताई गई हो क्वेश्चन में, तो आप डायरेक्ट ये फॉर्मूला यूज करेंगे दैट वर्क डन इज फोर्स इनटू डिस्प्लेसमेंट. सेकंड मेथड, समटाइम graphical questions are also asked regarding work done, that what is the work done. For example, like this. Here the value of force applied is given and here is the distance travelled by the body. Suppose a force of given value 2 Newton is applied on a body from point A to point B. The body displaces this much. This is the initial position and this one is the final position. Then how we will calculate the work done? In such type of question, work done is equals to area under the graph. We will simply calculate the area under the graph. How we can calculate area? As you can see, this is the shape of a rectangle, and if we have to find out the area of rectangle is length into breadth. So this value is our displacement and this much is the value of force applied. So we will simply write F into S and we can easily calculate our work done. This is the second method to calculate work done when graphical questions are asked and graph is given between force and displacement. Suppose any another graph is given like this. Like this one is the type of graph given to us. Then what we will do? We will calculate the area under the graph. This is the shape of a trapezium. Then what we will do? We will calculate the area of trapezium. Suppose the shape is given like this. Your graph is like this and you have to calculate the work done. A to B and B to C and C to again A. Then what we will do? We will simply use the formula that work done is equals to area of this triangle. How we can calculate the area of triangle? 1 by 2 into base into height. And this base is equals to displacement and this height is given by the force value. So in this way we can easily calculate our work done by graphical method. There is one more method for the calculation of work done and that is work done is force into displacement into cos of theta. What is this theta? Theta is the angle between direction of force and displacement. Theta is the angle between force and displacement. And this cos is a trigonometric function and cos theta will be provided with you a definite integral value. So suppose it is given that there is a toy and one boy tie a thread with this toy and hold it in his hand here, and when he starts pulling, then this toy will move on the surface in this way. That means the force applied is in this direction and the body is moving linearly on the surface. Then there is a angle between force and displacement. Suppose the value of this angle is 45. Then how you will calculate the work done? Then we will calculate the work done by using this formula. Force applied, write the value. Distance covered, write the value. And also write the value of cos 45 degree. And cos 45 is 1 by root 2. So we will multiply by 8. Students, at 9th standard, no need to confuse with the values of this. If any question related with angle is given to you, the value of that cos theta will be provided. So you have to just place the value, do the multiplication and solve your numerical. So work done will be calculated like this. Work done is force, displacement and cosine of given angle. So these are the three simple methods to calculate work done. Now we will move ahead. Our next topic is types of work done. How many types of work done? How we can classify different work done in science. In our daily routine, work is work. If it is of any physical work, mental work or any entertainment work, daily routine, that doesn't matter. But in science, work done is of three types. Now we will discuss types of work done. First type is positive work done. Second type is negative work done. I'll write it in complete form. Negative work done. And the third one is zero work done. How we can define positive work done? What do you mean by positive work done? This work done is simply related with this formula F S cos of theta. If the value of theta is 0, theta is the angle between force and displacement. So we can also say that the direction of force and the direction of displacement must be same. जिस डायरेक्शन में हम फोर्स लगाते हैं बॉडी भी उसी डायरेक्शन में अगर मूव करे, then we will say the direction of force and displacement both are same and the angle is also 0. In this case we will get the result that work done is positive because the value of cos 0 is 1. When we will multiply it by 1, we will get 1. There is no negative sign, so we can say the work done is positive. So how we can define? There are two conditions for the positive work done. First one, angle theta is 0. Second condition, the direction of force and displacement must be same. Then we said work done is positive. How we can define examples in the favor of positive work done? Suppose we are applying a force on a body and this body displaces in the forward direction. After traveling as distance, this body comes here. So the work done by this applied force is positive. हम किसी भी चीज को पुश करके सामने की तरफ अगर मूव करवाते हैं, that is the example of positive work done. As like in your art integrated project, whenever a player kick the football, he kicked the football in forward direction and the football also moves straight, so the work done is positive. जिस डायरेक्शन में आपने फोर्स अप्लाई किया है उसी डायरेक्शन में अगर बॉडी मूव करे तो उसे हम पॉजिटिव वर्क डन कहते हैं. नाउ द सेकेंड टाइप ऑफ वर्क डन इज नेगेटिव वर्क डन. As the name suggests, negative work done means there must comes a negative sign in the formula. And again we are using the same relation that F S cos theta is equals to work done. And the condition for negative work done is if theta is 180 degree. Theta 180 means the force and displacement are in opposite direction. Force अगर सामने की तरफ लग रहा है तो बॉडी बैकवर्ड मूव कर रही है. That is the case when force and displacement are in opposite direction. And the value of cos 180 is -1. So we will put here work done is F S multiplied by -1. So we will get our result as negative. So this type of work done is known as negative work done. What are the examples of negative work done now? As we know, friction is the opposing force. Suppose this is a rough surface and we are displacing a body here. We applied a force F in this direction, but the frictional force exists in opposite direction. Frictional force हमेशा opposite होता है applied force के. So when the body displaces by some distance, that is S, then work done by this frictional force is always negative. So these are the examples for negative work done. वो फोर्स जहां आपकी डिस्प्लेसमेंट अपोजिट होती है वो फोर्स हमेशा नेगेटिव वर्क डन करता है. सेम एज लाइक ग्रेविटी. ग्रेविटी चीजों को नीचे की तरफ पुल करती है, बट अगर आप अगेंस्ट द ग्रेविटी बॉडी को ऊपर लेकर जाएंगे तो वर्क डन हमेशा नेगेटिव होगा, बिकॉज वी आर गोइंग इन अपोजिट डायरेक्शन टू द अप्लाइड फोर्स. So the condition for negative work done are two. Theta must be 180 and the direction between force and displacement both are opposite. Now come on third type, that is zero work done. How we will define now zero work done? Again we will use the same relation that F is equals to W is equals to F, S and cos of theta. Here the condition is that if theta is 90 degree, 90 degree means force and displacement are perpendicular to each other. We are applying force on a body in perpendicular direction, then we will get zero work done because cos 90 is 0. So what we will do? We have force, we have displacement, but we have 0 value. When we multiply any number by 0, we will get our result as 0. So this is the case of zero work done. हम फोर्स भी अप्लाई करते हैं, बॉडी में चेंजेस भी आती हैं, लेकिन स्टिल वर्क डन इज 0. Why? Because the angle between force and displacement is 90 degree. So how we can define these examples? Work done can be 0 if force is 0. If you are not applying force, then work done is 0. If the body doesn't move, आपने दीवार को पुश किया बट दीवार अपनी जगह से नहीं हिलती है, displacement is 0, so the work done is 0. But one more special case is there, you are applying force, the body is also showing changes, but still work done is 0, and the reason is the angle between force and displacement is 90 degree. And the example for this condition is gravitational force. Whenever the gravitational force acts as a centripetal force, as we have studied in 9th chapter, that suppose this is Earth and Moon is revolving around it due to gravitational pull of Earth. That means every time Earth attracts Moon towards its center, and but the direction of motion of Moon is perpendicular. So the angle between force and displacement is 90. So there is no work done by the gravitational force of Earth to revolve Moon around it. These are the examples of zero work done.